This is the instructional video for Lab 8. We will conduct a market research blinded taste test. The subjects do not know which product is which, using expert students as judges. A company producing bargain brand products would like to know if its products are preferred equally by college students, based on taste alone, to similar name brand products that are highly advertised and more expensive. We're going to use the following factors to reduce influences other than taste on student selections. The experiment is single blinded. That means that the administrator will know which product is the bargain brand and which is the name brand, but the participant will not know. Administrators will randomly assign the label Y or Z to the bargain brand name product. So one product will be labeled Y and one product will be labeled Z's. And we're going to randomly pick which one's Y and which one is Z. We're also going to randomize the order of presentation. Some participants will receive the name brand product first and the bargain second, while others will receive the bargain brand first and the name brand second. Students should not say their preferences out loud in case this might influence the responses of others. Students should also close their eyes during the taste test so that they will not be influenced by the appearance of the product. So all of these steps are done in order to try to limit any other influences, like somebody else's answer or what the product looks like. We want students to pick their favorite based only on taste. We will study Keebler fudge strip cookies and Publix fudge stripe cookies. Each student will taste both cookies without knowing which is which, and then identify which cookie they thought tasted better. Now, since the labs are being done at home, I will be doing the data collection and you will watch the video to see the methods used and to record the data. So everything I'm going to show you in a video you would have done in the labs if the labs had been meeting in person. Methods. Let's first start with our randomizations that we're going to do. We're going to randomly assign which cookie will be labeled Y and which cookie will be labeled Z. We'll do this in StatCrunch by simulating a Bernoulli with one row, one column, and P equals 0.5. Bernoullis have values of either 0 or 1. They are binary. So we're going to have StatCrunch randomly pick a 0 or a 1, and they're both equally likely. You will record the Bernoulli observation on page 61. Then you will fill in table 8.2 on page 61. You're not actually going to do the simulation. I am going to do the simulation and we are all going to use the same value. But you do have to record it in your lab manual. If the value the computer generated was a 0, then the bargain product, the Publix product, will be labeled Y, and the name brand, the Keebler product, will be labeled Z. If the result was 1, then the bargain brand, Publix, will be labeled Z, and the name brand, Keebler, will be labeled Y. Then we will determine the order of presentation for each participant. Now, table 8.4 in the book is where you're going to enter this information, but that table only has 20 rows, and we are actually going to use a sample of 44 people. So you're going to need 44 rows, so you're going to need to create a new table, just like the one in 8.4 in the book, but with 44 rows instead of 20. I will do this step in StatCrunch, and you will watch the video. We will simulate 44 different Bernoulli observations. So 1 and 0 are both equally likely in StatCrunch. and you will fill in the Bernoulli column in table 8.4 on page 62. Then you will fill in the remainder of table 8.4. If the result on the row is 0, then Y gets tasted first and then Z. If the result is 1, the participant would taste Z first and then Y. Remember, we don't want everybody tasting the same product first. We want to randomize that. So I'll now show you the simulations that you'll need to record in table 8.2 on page 61 and the created 8.4 with 44 rows, which you can find on page 62. So I'm now going to simulate the data so we can determine whether we want the Publix brand or the Keebler brand to be labeled Y or Z. So again, generally in lab, you would have done this step in your group. However, because the labs are done at home, we're all just going to use the same information. So data, simulate, Bernoulli, 1 row, 1 column, and 0.5. You're going to value of 1. Everybody needs to record this value on page 61 of the lab manual. With a value of 1, Publix is going to be labeled as the Z brand. Now we're going to prepare our product for the taste test. We're going to place 44 Keebler cookies in cups labeled Y, and then place 44 Publix cookies in cups labeled Z. Alright, so we've set up our experiment. We have 44 cups of Z, which contain a cookie in it. So all of the Z's are Publix, and there's 44 cups. Here are 44 Y's, which contain the Keebler cookies in it. So everybody gets to try as well. And the last step is to actually administer the taste test to participants. We will do this following the order of presentation in table 8.4 and give each student one product to taste first and then the other product. I have set up the experiment so that the order is already set up. So everyone will taste the cup to the left first and then the right cup. Students should hand the administrator the cup of the product they preferred. The product preferred should be recorded in table 8.4. So everybody gets to taste two things. The order in which they taste them is determined by table 8.4. They should then hand the administrator the cup of the product they preferred, and that data is recorded in the last column of table 8.4. So you can see we've set up our cups now so that each one is in twos. So rows 1 through 15, the first observation gets Z first, and then Y. The next one gets this cup first, and then the second cup, so on and so forth. So we've already sorted them in groups of 2. So when a participant comes up, I hand them the first choice, and they taste it, and then the second choice, and they taste it. These were the 44 preferences for the 44 people participating in our taste test. Again, we used the order of presentation, what they tried first and second, based off of our table. And these are the results you should record in the last column of table 8.4. Everybody can just pause the video as needed to record their preferences. The next steps, you should now have all of table 8.4 filled in. And you should be able to summarize the information in table 8.4 onto table 8.5 on page 62. So go ahead and fill in all the information in table 8.5. Then you should be able to answer the discussion questions. Keep in mind that this was not a random sample, but we will pretend it was for the purpose of doing the inference methods to make predictions about the population proportion. So in order to use inference, you do need a random sample, all right? We don't actually have a random sample, but we're still going to do the methods for the confidence interval and the hypothesis test. You can use StatCrunch to perform the confidence interval and the hypothesis test if you want to. Now, you should be able to do it by hand if you choose, but if you would prefer to do it in StatCrunch, that's fine. In StatCrunch, you go to Stat, Proportion Stats, One Sample with Summary. And then all you need to do is enter the value of X and the value of N, which you should have already found in table 8.5. So you can use StatCrunch to get your confidence interval, your hypothesis test output, and things like that. When you are done, make sure you turn in or submit all tables and figures completely filled in from pages 61 to 62. Also, make sure you answer all the questions on page 63. You can turn in pictures or scans of any handwritten work from the lab manual, or you could submit everything in a Word document found that you've created. If you submit a Word document, make sure it contains everything, even the tables and figures on page 61 and 62. Anything missing from your lab report will result in a deduction in the grade.